Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi Michael, Happy New Year. Finally it happened.
Yeah, absolutely.
First episode in 2023, and this is the most boring topic I can imagine. But it was requested, right? So, and I have something to say about it. So let's talk about transaction ID wraparound prevention, not when wraparound occurs, but how to prevent it. Well, we will probably touch the topic of how to deal if it happened finally. So transaction ID wraparound.
And I'm guilty of choosing this one. We had a couple of, I think this is the first topic we've ever had two requests for the same topic. So hopefully there's at least two people out there that don't think it's boring.
I think it's in my opinion, this is the most boring topic, but it's also the biggest fear of DBA. And let's try to explain it for backend developers and so on, because actually oftentimes the probability of this very bad event to occur depends not only on DBAs but also on how application is developed, how fast consumption of real transaction IDs is happening, right? So we should think about it from developer perspective as well.
Yeah, absolutely. And I guess it's worth saying that we really hope that the people listening to this never face this issue in their entire careers, but hopefully we can leave people with a few things to look at, to monitor, to tune in order to minimize that chance of it ever happening to them.
Right. Where should we start?
I think it is worth covering a little bit about what this issue is for anybody that's new to it, has never heard about it before going into how to avoid it. Do you think that's sensible?
Yeah. Well, the best description is a very detailed description, and I can recommend PostgreSQL internals two actually books. One is fully online, another is PDF, fully translated to English from Russian author. One is from Japanese author, another is from Russian author, Suzuki and Rogov. And both are quite good explaining this. Usually this explained as we have 4 bytes to represent each transaction ID. And of course, 4 bytes, it means half of it is roughly 2 billion. Full space is slightly more than 4 billion. And of course, today it's not that much, not that many IDs, right? And to roughly, if you have, for example, 1 or 2 thousand transactions per second, it will take roughly 1 month, depending on how stable your traffic is, your workload is. It will take roughly 1 or slightly more months to reach the limit. And what happens if you reach the limit? We discussed a few times that each tuple, so physical raw version, has xmin and xmax and ctid virtual column. So xmin, this is like a birth date of tuple. It holds transaction ID which created this tuple, and this also 4 bytes only, and of course it should be 8 bytes these days. And there is work in progress. There is a big thread in Hackers. Some Postgres variations already implement 8-byte or 64-bit transaction IDs. But of course, it's a big redesign, because currently all tuple headers, they are with padding alignment, they are 24 bits, right? 3 bytes only. But if you need more, you need to increase it. So our page is also limited. So it's a big redesign and big change of behavior. But of course, we should have 8-byte transaction IDs. But what happens if you fill this with 4-byte only transaction IDs? At some point, you need to start from 0 again, basically, from 1. Well, there are some special transaction IDs, especially until 9.6, but it doesn't matter. So you're already overlapping, so wraparound happens. And to avoid this, there is a mechanism called freezing. And this is one of main tasks of vacuum and auto vacuum. And auto vacuum does freezing all the time. Sometimes it's like so-called aggressive freezing, so like I need it right now. Sometimes it's regular freezing. But what it does says, okay, this transaction ID is this number, but we think it's in the past by all means. So even if this number is bigger than the current transaction ID, we know that it's from like previous epoch, right? So it's like definitely from the past, and it's achieved by placing additional bit, like frozen bit, and if all tuples in page are known to be frozen, all page is also marked as all frozen, and there is a visibility map. It holds 2 bits for each page, one like all visible and another is all frozen. And if page is all frozen, it means that everything, all tuples in this page are from the past. And it's good because next time AutoVacuum will process this page, it will just skip it because it's all from the past, nothing changed, good. So usually these articles have a picture like circle, and half of circle is our past, half of circle is our future, and we are rotating. And if we freeze our tuple or whole page, we just think it's outside of our circle. It's definitely from the past. So that's actually it in terms of theory. But the problem is that there are several handles, several knobs that DBAs can tune. And usually there is, if we have a huge table, usually this aggressive freezing happens quite early, at 10% of capacity, so 200 million transactions, and we already need to freeze it as soon as possible. And you can see in pgist activity that AutoVacuum is running in transaction ID wraparound prevention mode to prevent transaction ID wraparound. And this is quite interesting behavior. We will discuss it later. But discussing all this boring stuff, question to our audience: do you have in your monitoring transaction ID wraparound prevention graph and alerts? And
by that, do you mean the number of remaining transaction IDs?
For example, right?
Yeah.
For example, so we should sometimes under certain circumstances we will discuss it in a second. Yeah.
Before we move on from the theory side of it, I think there's an interesting point about the name here, and I've always called it. I've always seen it referenced as transaction ID wraparound, but I think I actually prefer another term I came across, which is transaction ID exhaustion, which I think describes the problem a bit better, because it's like we have this finite but ever-changing number of IDs left, and it's by exhausting those that the problem occurs, because Postgres will prevent us from wrapping around. It will stop
Right.
having. So that's really useful for my understanding, because the failure case here isn't wraparound, which would cause things like basically corruption in various forms. Now Postgres sees that as worse than downtime, I assume, and what it will instead do is eventually enter read-only mode. And that's
Right.
That's really bad for applications that want to keep sending data, of course, but it's not as bad as the alternative. So ID exhaustion, transaction ID exhaustion, appeals to me more as a term.
Well, yeah, right. I like this term, but wraparound shows that it's
Yeah.
rotating, right? But also, in some cases, I saw wraparound word used in positive meaning. For example, we have wraparound because we are starting to use the same numbers again. And if you say wraparound happened, it is something negative. But maybe positive. So there's some ambiguity here in terms of meaning, but yeah, exhausted ID. It's also good to say, but like I forgot to say what you're right. I forgot to say what will happen if we, for example, the vacuum cannot perform freezing, and obviously Postgres at some point will say only few IDs left to be used, and exactly it will be it won't process transactions anymore, and you will need to perform freezing basically, and it will take many hours usually. Like it will take a lot, maybe days.
The question I have on this actually, I think I read that the first warning in the logs is at 10 million IDs left. That seems, considering all of the other defaults in Postgres, that seems like the least conservative one I've ever heard. Yeah. Like, I guess it. Anyway, I'm not. I guess it,
warnings. I don't remember, but yes, I don't remember this. But I wanted to say there are several blog posts to learn from other people's disasters. For example, from Sentry, also from Mandrill, Mailchimp's project, which also experienced this a few years ago. And obviously, everyone. This is the biggest fear of everyone who uses Postgres. So.
I thought both were excellent blog posts, but I don't think either did a great job of explaining how to avoid. Go on.
Yeah, back to your note about logs. You know why I don't know? Because who reads logs? And if you even read it, you should have alerts, and this should be like critical alert. And
yeah, but I would suggest it be way before you're down to 10 million left. Like it, yeah. But what would be a sensible?
I would suggest this threshold. I don't remember. I always forget knob names, but default is, as I said, 200 million transactions. So this is like when aggressive freezing happens. And I would suggest doubling it, just taking the current value and having alert when we reached 2 times of this value. And actually, if you have reliable alerts, I would suggest considering increasing this threshold, because 200 million, like 10% of capacity is, I would use at least 20%, 30, maybe 40 if you trust your alerting system and so on, because of course there is big overhead from doing this, right? But this is usually when we discuss this with our clients. Of course, there are different opinions, and it takes time to reach consensus, because, of course, people feel fears, like, okay, this default threshold, 10% of capacity, maybe we should not touch it. Well, default was created in thinking that maybe you don't have monitoring, right? If you have reliable monitoring, you already can postpone this point when aggressive freezing happens. Why aggressive freezing is bad? Because it will block you. Usually auto vacuum, when it sees that it blocks someone, it stops, like harakiri, right? So like stopping itself. But if it's doing this to prevent transaction ID wraparound, it won't yield, and your DDL will fail. So you cannot deploy your changes anymore. And even if you kill it manually, which is fine actually in some cases, if you need to deploy something as soon as possible, you see that capacity used is only 10%. So it's very far from this limit. You decide to kill it in favor of doing deployment, and then it starts immediately. This is the problem. Like it ignores enough time and everything. Like I'm starting I'm not yielding, I'm starting, that's it. So what you do, you start your deploy and immediately kill this auto vacuum, and only in this case your DDL proceeds. But then if you need more DDLs in sequence, it starts again. So it's nightmare actually. And unfortunately there are parameters per table, so you can adjust this threshold per table, but you cannot change them without restart.
Okay.
So you need to manually fight it back, like stop. That's why I think like sometimes you need to adjust your threshold and try to avoid times when it happens. So
should we cover some of the more basic things? So I've got some ideas here for things that I've seen people doing that would increase their risks of this happening to them. Obviously, monitoring and good alerting is a great remedy here, but things that might start to get you in trouble. I've seen people turning off auto vacuum, which seems like you know, that's an easy way of starting to get into this kind of trouble.
Well, as I remember, I may be mistaken, but if you turn off auto vacuum, freezing, this aggressive freezing will happen anyway. As I remember, I might be wrong here.
I think you're right, but for example, if you then have one of the other mitigating factors, then you haven't had, you know, I think the freezing also happens at other points. It has like a min age and a max age. Is that right?
So you can block auto vacuum from doing freezing if you have, for example, long transaction. And here I should mention that usually people say we have long transaction and it's bad because from over time I achieved some conclusion that long transaction is only it's only bad in terms of locking issues. So it blocks others because it holds some lock. But when we talk about auto vacuum behavior, freezing, and so on, we should say not long transaction, but instead X-min horizon. It will include all aspects of it. It's possible to have. By the way, I bet your monitoring doesn't have it properly. So because somehow people try to invent wheels different ways, but there is concept X-min horizon. If you have transaction which have assigned XID, or regular transaction ID, it will hold this X-min horizon. X-min horizon is the oldest transaction which should be used in the system, so vacuum cannot remove the tuples which were deleted later than that transaction. And if there is ongoing transaction with some number, regular transaction number, not virtual. I will explain virtual in a bit. So in this case, vacuum cannot delete that tuples. But not only this. If, for example, you have replication slots and physical replication, and standby node also reports transaction ID that needs on that. So hot standby feedback is on, so it reports also transaction ID and also can hold X-min horizon. And finally, sometimes in some cases, as I remember, analyze can hold it. Also index creation is holding X-min horizon. There was an attempt to improve this, optimize it in Postgres 14, and until Postgres 14.4, it was corrupting indexes, so it was reverted. It would be very good optimization, because if, for example, if you have a huge table and you need to build index, obviously you will hold X-min horizon for long, and it will affect auto vacuum behavior. Usually, you need to understand how fast is your transaction ID consumption rate. If you are a developer, you're thinking, you design your system, it would be good to understand, for example, per second, per hour, per day, how many transaction IDs we will consume. The good thing is that if you're just selecting something, you are not consuming transaction ID. There is a concept of virtual transaction ID, and it's coming for free. It won't increase this transaction ID counter. But if, for example, you're writing something or you call tick-seed current, this is old name of function. It was there is PG current exact ID. I always forget it. I wrote it here. So if you call it, you will either return from your transaction ID, real transaction ID, which is already assigned, or it will assign a new transaction ID. By the way, this is the way to simulate transaction ID wraparound prevention. You block freezing, opening some transaction, and in another session you start running this tick seed current very, very quickly to consume a lot of seed transaction IDs, right? And in this case, if, for example, if sometimes I see design when application performs a lot of rollbacks, it's probably a sign that we don't think about our transaction ID consumption rates, and we like are not lean, right? So we like did something, rolled back, and transaction ID lost here, like, I mean, wasted. And you should be more careful. Maybe rollback should be done less often. Normally, like social media, like workload is like 80 or 90% reads. They should not increase exceed. In this case, we are moving less faster, and if we hold Xmin horizon, we can say, okay, we hold it, but during a minute we will consume this number of exceeds, right? And it's fine. During 5 minutes, that number of exceeds, it's already not so good. During 10 minutes, it's already quite bad. And monitoring Xmin horizon, this is great thing to start thinking about our behavior. And good news is that if we have smaller tables, meaning partitioning, right, we have more pages which are frozen and touched less often, because this is like kind of old data. And in this case, we have several good behaviors of our system. For example, if we create index, it's much faster, right? So we don't hold Xmin horizon. And auto vacuum is much more efficient because it can skip more pages because they are frozen. So what I'm trying to say is, by using partitioning, you can radically decrease chances of transaction ID wraparound, which is probably quite like underestimated topic. I didn't see articles discussing this, but it's obvious to me. So don't have large tables.
Yeah, I think that's an awesome observation. It also occurred to me that it would help with recovery, reading through a couple of the blog posts, but it hadn't occurred to me that it would help with prevention, which is really cool. Something you mentioned...
You can also, if you consider a huge table, for example, terabyte, and you cut it to partitions, you can parallelize processing, because auto vacuum, one worker can work only with one table, but if it's 10 partitions, already 10 workers can be involved. And I recommend having many workers, because many, I mean, like, take your number of CPUs and consider having up to like 25% of those CPUs as number of workers, because by default it's only 3. It's very conservative, not good for modern hardware.
Well, and I think this was one of the key causes of the Sentry one in particular. They said they still had the default of 3 auto vacuum workers. So maintenance,
The big idea of this episode, if like many things are discussed, but big, like if our listeners will try to get only one thought, it's without help from developers who should implement partitioning to avoid tables roughly like, say, 100 gigabytes in size. If you exceed 100 gigabytes, partitioning should be there. Like, without help from developers, DBAs won't be able, like, their work will be very tough to prevent transaction ID wraparound, to handle this and so on. Because even if you need to create index on huge table, it's already a lot of headache. So developers, please use partitioning earlier. And by the way, this empiric rule, 100 gigabytes, we discussed it with several people. And for example, Kukushkin also told me, like, 100 gigabytes partitioning needed. 1 terabyte, maybe sharding needed already, right? Well, It depends, but operational costs are increasing. So I spent some time thinking. Sometime I mean months. I was thinking, why 100 gigabytes? Why 100 gigabytes? And now I can say, of course, it depends on your system, how fast you consume transaction IDs. But if you think about it, and you can think about this X-min horizon, and you consider how long it takes to create, for example, index, and during creation of index you hold X-min horizon, and you're already understanding. This is like for engineers, for developers actually, to understand these thresholds. And you understand, okay, to create an index on 100 gigabyte table, it takes this time minutes. During this, we will hold X-min horizon, and it means that freezing won't be possible and so on. And we can conclude, okay, we can afford only this number of minutes. And this, so I mean, I don't have good math here, but I have sense that it's possible to create math here and say, this is acceptable for us, like create SLOs, like service level objectives. It's okay for us during daytime when we have this number of transactions per second, writing transactions per second. It's okay for us to hold X-min horizon during this number of minutes. So this dictates how long index creation should be, and this introduces some limit for table size, right? And this is quite interesting because this is already like explainable limit for developers to understand why they should do it.
Yeah, it's also a really nice round number. That's easily remembered.
Well, yes. Well, this is from a lot of pain and experience derived from it. But we can, observing these numbers, understanding how fast our transaction ID is spending, we can have a good math and say, for our system, it's like 50 gigs or 200 gigs.
Yeah.
Because we have very good, like very, very fast disks, for example.
Yeah, I think that's a really good point. I want to go back to something you mentioned earlier, which was around the Postgres 14 issue. Now, I'm a bit scared because I thought this might be in Postgres, and I'm scared it might have been reverted. There was some new logic, I believe, put in. One of my tips was going to be to upgrade to 14 or above, or 14.4 or above, because I think I saw a feature in there that would now more aggressively prioritize a freezing version of Vacuum. Whereas in the past, it wouldn't necessarily, you'd get a full Vacuum. And I'm reading the blog post, a lot of people are running a full version of, not Vacuum full, completely different thing, but but Vacuum. And I think I saw a tweet by Peter Gagan. I actually shared this in my newsletter back in 2021, but this was before the version 14 release, so around January, February time. He recommended, if you are ever in a situation of recovering from Postgres shutting down due to this issue, he recommended running Vacuum's in index cleanup option, which just does
to turn off
stuff.
processing of indexes. Yes, it's possible.
Yeah. Now,
it will speed up freezing.
Yeah. Now, there was some interesting, I think, is it Rob Treat, I think, replied to this saying, could Auto Vacuum do that automatically? And I thought he added something in version 14. I thought Peter might have got something into version 14.
I don't remember this. Maybe, or maybe I don't know. But if we discuss recovering from this very bad state, I'd recommend rewatching or watching Postgres TV episode with Hannu Crossing from Google Cloud, because Hannu explained that single mode is not needed, and even more, it's using single mode to get out of that bad state is even less productive because you don't see details. And he developed a recipe how to escape from the bad situation using regular mode. So it's quite good. And the episode is called "Do You Vacuum Every Day?"
Yeah, so excellent interview.
Excellent. It was a talk, open talks.
You had a lot of questions. Yeah,
silly questions.
There were, but the reason I brought this up was I think it's another. I kind of always want to bang the upgrade drum, but if you're in a heavily loaded system, there are good features in higher versions of Postgres that have your back on these kinds of things. As more companies and people are hitting these kinds of issues, the developers are listening and they're adding features to try and prevent it, to try and make these things less likely. Well, you say of course, but I see a lot of big companies that are scared of upgrading their data, still on out of support versions of Postgres, like 10, 9.6.
If you recommend anyone to upgrade to 14.0 right now, it would be a mistake, right? But it is or 14.3. But this was a recommendation during many months after version 14 released. So it's the fears have some basis to happen, right? So there are pros and cons, but of course, if you can, you should have a newer version always. It's obvious, right?
Yeah, but I think these are some of these aren't always like shouted about. I looked in the release notes and it was quite far down the release notes that this kind of thing came up. But yeah, I agree. But I think 14 was a bit of a blip, 14 to 14.3. I don't remember issues like that from 10, 11, 12.
But it was so
13,
good optimization.
15.
For indexing, reindexing, not holding X-min horizon. But without this optimization, we can state partitioning is a must if you have large tables or will have large tables. You should be prepared for partitioning. Speaking of transaction IDs, I mentioned that like there is normal transaction ID or virtual transaction ID, but there is also third type. And I already said, like check your monitoring. Probably you don't have this or that. I bet like 90% probability that you don't have, even if you have transaction ID wraparound prevention alert, you don't have multi-exec transaction ID wraparound prevention alert, because usually people just forget about it, and even big monitoring systems forget about it. Of course, chances are lower. So multi-exec ID or multi-transaction ID, it's additional mechanism of it's a separate space of transaction IDs, and it's used when multiple sessions are using some lock. Some example is using foreign keys. If you have foreign keys, you are multi-exec user. And it also can be exhausted. So it should be also monitored. And most monitoring failed to remember this and implement it. And trick there is a function H that allows you to understand the difference between two exceeds. But for multi-exec IDs, you need to use mxceed H or something. This is what I usually fail to understand, and trying to add multi-exec ID monitoring, at least manual or into some like Grafana, Prometheus or something. I usually forgot to remember that H function is different. So this is tricky. But it should you should have monitoring of two edges, of two capacity used, of two spaces. Regular exceeds and multi exceeds. Virtual exceeds are not should not be monitoring. They are not a problem at all. So this is actually maybe it in terms of recommendations where to look at. And I think if you are Postgres user, you should think about it. Even if you're not DBA, you should think about it, because as I said, if you are using exceeds too fast, you should optimize for it. You should use regular exceeds less often. You should also use partitioning, right? Also, by the way, subtransactions, they also increment. In my article about how harmful some transactions in current implementation in Postgres are, this was maybe I had 4 items, and this was item number 1. The use of subtransactions leads to regular exceed consumption. So you have nested transactions. Each subtransaction is +1 to regular exceed. So
in the developer's mind, definitely before I read that article, I was thinking a transaction with subtransactions. In my head, it was one transaction.
Right.
and therefore I would have guessed it would be a single transaction ID. But that can be very wrong,
It's the
especially
same
if
space.
yeah, super interesting.
In my opinion, in current form, if you want to be prepared for heavy load, you shouldn't use sub transactions at all, because dangers are numerous, and not numerous. There are 4 dangers I enlist in my article, but they are so painful. So, and one of them is related to multi-exact ID as well, and foreign keys. But good news is that it should be improved. There's work in progress to improve sub-transaction behavior, and also Alexander Korotkov recently I had open talks on Postgres TV with him, and his project OrealityDB is actually solving this already. So sub-transactions will be much better. And
Nice.
right. And
Wonderful.
also, OrealityDB, as I remember, has 64-bit transaction IDs already. So this wraparound problem gone. It's so good.
At least for a few thousand years.
Yeah, I think
That's all we-
this episode won't make sense in some years, like 5 years maybe. When
I hope so.
Yeah.
That would be success, I think. Awesome. Thank
Maybe
you so
earlier,
much.
Actually, maybe earlier.
Yeah, fingers crossed.
Well, I also wanted, for developers, I wanted to remind that there are a couple of good extensions to
Yes.
to look into internals, and they're quite easy to use. First is Page Inspect, and actually there is also, if you're a Linux user, you can even have like kind of hex editor to look into pages from Peter Gagan. I don't remember, PG Hex Edit or something it's called. It's like additional visualization on top of Page Inspect. And also PG Visible, which inspects visibility maps. And as a reminder, visibility map it's not only about all visible bit, it's also about all frozen bit. So it's useful to inspect and see which pages are marked as all frozen. So it's good to understand what's happening. Right.
Yeah, absolutely. I like that. And remember to tune auto vacuum, people. That's probably, even if you're on a smaller database, there's a lot of benefits.
Right. But cloud vendors do it already a little bit.
Yep.
Your DBS probably will do it. If you hire some good teams as Postgres AI consulting team, they also will do it. But what they won't do instead of you people is partitioning. Use partitioning, please.
Yeah. Good
Partitioning
point.
is a must for large systems.
Wonderful. Anything else?
I think that's it. It's already too much, right?
It's great. Thanks everybody for listening. Thank you, Nikolai, and see you next week.
Yeah, by the way, final words. This was a topic, as we said, from our listeners. Again, thank you so much. Please continue delivering ideas. That this is great to have ideas, and we just choose one of them and discuss. That's great. Thank you so much.
Or even if you just review the list of ideas there already and let us know which ones of those you're most interested in.
Right.
Yeah, exactly.
Right.
That'd be great.
Okay, that's
Take
it.
care.
Thank you. Bye-bye.
Bye.